Interestingly, there has been a shift, a change in the naming convention, the preferred way for labeling polygon vertices. The way in which we label a quadrilateral ABCD or a pentagon ABCDE, the way in which we label the vertices, the preference has shifted, the convention has shifted. If you could see old textbooks, maybe belonging to your grandfather's time, they started from top left and went clockwise A, clockwise B, clockwise C, and clockwise D. Most of the modern textbooks, they start from bottom left, not top left, bottom left, and they move anti-clockwise A, anti-clockwise B, anti-clockwise C, anti-clockwise D. So the starting has shifted from top left to bottom left, and then instead of going clockwise, they go anti-clockwise. So this is the difference from the old system to new system, and there is a specific logic behind this change in naming convention, behind the preference for changing the naming convention, starting from the bottom left instead of top left, going anti-clockwise instead of clockwise. So the specific reason behind this change in naming convention, this is what we will discuss today. In most of the older textbooks, the vertices naming started from the top left and went clockwise A, B, C, D. Starting was top left and clockwise A to B, B to C, C to D. In most modern textbooks, the convention has been reversed. They start from the bottom left, see A here, bottom left, and they move anti-clockwise, not clockwise, they move anti-clockwise, A to B, B to C, C to D. So the starting point has shifted from top left to bottom left, and the order is not clockwise, but nowadays anti-clockwise. Why this change? We will discuss it and try to explore the logic and the reason behind this shift in the labeling convention of polygon vertices. The shift in polygon vertex naming convention from starting at the top left and moving clockwise, the older system, to starting at the bottom left and moving anti-clockwise, the new system. This change, this shift, reflects a move toward greater mathematical and computational consistency, particularly in geometry, computer graphics, and mathematical algorithms. So in order to be consistent, consistency with mathematical and computational, particularly geometry, computer graphics, and mathematical algorithms, in order to be consistent with them, they have shifted from starting from the top left to starting at the bottom left and going anti-clockwise instead of clockwise. So the shift in polygon vertex is actually a very scientific, a very logical move. It reflects a move towards greater consistency with mathematical and computational processes, particularly geometry, computer graphics, and mathematical algorithms. So let us try to explore these in more detail. So historical and practical reasons. We are talking of the old system. We are talking of the old system when you started at the top left and moved clockwise. So clockwise naming in school textbooks, that means older school textbooks, Vertices were often named clockwise, starting from the top left, for ease of drawing and labeling, especially since diagrams were hand-drawn and teaching focused on visual understanding. Starting at the top left A and then moving towards the right. This is the way in which we write an English paragraph. Look at this paragraph above. Historical and practical reasons, clockwise naming, school textbooks. This paragraph, we have started at the top left and then we move towards the right and end at the right margin. So the same thing they wanted to maintain. So when diagrams are hand drawn, for visual understanding, for ease of labeling, it's much more comfortable for the student to start at the top left, because that's what they do when they write English. When they write a paragraph in English, they always start from the top left margin, the first line, the top left margin, and then go towards the right. So that is the convention they followed, starting at the top left and from A to B, moving towards the right. So it was for ease of drawing and labeling, because the teaching focused on visual understanding and diagrams were hand drawn. So for the students, it was more convenient to start at the top left, because that was the way in which they wrote English paragraphs. If they had to write an English sentence, they would always start at the top left and then move towards the right margin. So in keeping with that, they had the labeling consistency. The way, the style was consistent with what we did normally, uh, starting from the top left and from A to B moving towards the right. So that's the reason historically it was a very practical and pragmatic move to start from the top left and move clockwise. Then what changed the system to the modern system, starting at the bottom left and moving anti-clockwise? Modern mathematical and computational standards often prefer starting at the bottom left. In modern mathematical and computational standards, and that's what most math books follow, they prefer starting at the bottom left and moving anti-clockwise. Why? Because this matches the orientation convention in analytic geometry. In analytic geometry, the orientation convention anti-clockwise, where the positive direction is anti-clockwise and negative is clockwise. Think of an angle in trigonometry. If the line rotates in anti-clockwise direction, the angle is positive. If the line rotates in clockwise direction, it is negative, right? So the positive direction is the anti-clockwise. It is used for defining the interior, calculating area, applying the shoelace formula, and describing transversal. So for these purposes, we always preferred the anti-clockwise in analytic geometry. So that is the reason why, in consistency with analytic geometry, because positive direction means anti-clockwise, they have shifted to a anti-clockwise naming convention. So now they start at the bottom left and move anti-clockwise, because that is consistent with positive direction, that's consistent with the definition of the interior, calculation of area, applying certain formula. So all these, it would be consistent with the higher geometric and trigonometric concepts if we start at the bottom left and moved anti-clockwise. That's why the shift in convention, now starting from the bottom left and moving anti-clockwise. But there is more. But there is more than this. So let us point-wise discuss why anti-clockwise, why counterclockwise, why starting at the bottom left and moving in the direction as shown, the counterclockwise or anti-clockwise direction. Point number one, coordinate axis. In Cartesian coordinates used in mathematics and programming, the origin is often at the bottom left. Supposing you don't need the negative part, it all has to be positive, like population graphs. The 0, 0 will be always at the bottom left. The origin is often at the bottom left. You extend this line only if there are negative values. If there are no negative values, for instance, in bar graph, a graph showing the population growth, a graph showing, say, the poll results, a graph showing comparative GDP, when negative is not required, what do? You always consider the bottom left as 0, 0. And then towards the right positive, and also vertically towards the top positive. So that is, coordinate axis always considers the bottom left as the starting point 0, 0, provided you don't have any negative values. So that is the origin, 0, 0, bottom left origin. Making the bottom left start convention, it is convenient and consistent with coordinate axis convention. The coordinate axis convention, where in many of the graphs, the bottom left is 0, 0. Why anti-clockwise? Point number 2, mathematical orientation. By convention, traversing vertices anti-clockwise defines the interior of the polygon and the positive area. Otherwise, moving clockwise would be the exterior of the polygon and the negative area. So by convention, traversing vertices anti-clockwise defines the interior of the polygon and the positive area, particularly when you use certain formulae for area and computational geometry. Only going clockwise, it will give you a positive answer. Going anti-clockwise will give you a positive answer. If you go in the reverse way, you will get the same number with a negative sign. If the area is 36, you might be getting minus 36. So by convention, the way in which we write the formula, we have to move anti-clockwise to get the positive area. And that is what defines the interior of the polygon in mathematical orientation. So in consistent with that, it is recommended, actually it is necessary or highly and strongly recommended that we should form a habit, even when we are not applying this formulae, when we are not defining the interior, when we are not going by the higher mathematical orientation, higher mathematical convention, even then the habit is strongly recommended nowadays that you start at the bottom and move anti-clockwise, which defines the interior, which gives you a positive area when you apply certain formulae for area and for computational geometry. Why anti-clockwise? Point number 3. First was coordinate axis. Second was mathematical orientation. The third point, algorithmic consistency. Many algorithms, such as those for filling, rendering, and detecting inside and outside points. For instance, in computer, you want to draw a shape and fill it with a color. You draw a circle or a rectangle and fill it with color. Rendering and detecting inside and outside points. Inside you may have one color, outside you may have one color. So the computer will have to decide which points are inside and which points are outside. The algorithms are written in such a way that they assume counterclockwise vertex ordering. So if you reverse the ordering to clockwise, they may not function properly. All the algorithms may not work properly. So in the fields of computer graphics and spatial databases, so if you want to fill inside of this rectangle with blue color and outside with red color, so in all these cases, the computer must know, the algorithm must be very clear whether you want the point blue color that is inside or outside, the point where you want red color inside or outside. Every pixel has to be determined as inside or outside. So the algorithms are written in the counterclockwise vertex ordering. The vertex are ordered counterclockwise in the algorithms. So if you reverse the system and write it in a clockwise, it may not function properly. So for computer graphics, these algorithms for filling the color and detecting inside and outside, detecting the points, which is inside, which is outside, which point should be filled with red color, which point should be filled with blue color. So for this, the algorithms are written in such a way that they assume that the vertices shall be named anti-clockwise. So if you do not name them anti-clockwise, the algorithms may not function properly. So that is the reason why even at the basic stage for a class 4 child, the habit they should form is always move anti-clockwise. So that's the reason even when these things are not required and class 4 child is just is drawing a triangle, or a class 6 child is just proving that the sum of the angles of a triangle is 180 degrees. Although this is not important, but it would be important in higher studies. That's the reason why it is important to put the thing, the hammer the thing in the child's brain that we should move counterclockwise. And for moving counterclockwise, we have to start at the bottom left. Why anti-clockwise? Point number 4, standardization. Most current books and mathematical texts require consecutive vertex ordering, but starting vertex and direction can vary. However, anti-clockwise is generally preferred for consistency across platforms and proofs. So the international textbooks, the international conventions, if you go to an artificial intelligence to say the vertex ABCD, the rectangle ABCD, it will assume that it is in the anti-clockwise order. So the current textbooks and all the mathematical papers, they prefer a consistency, uniform standardization. And in order to adopt a uniform standardization, counterclockwise order is preferred so that you are consistent. Not that sometimes you do it clockwise, sometimes you do anti-clockwise. Let it be fixed. Let it be standardized. Let it be uniform throughout the world, that whenever we are talking of polygons, we will always be talking about vertices in anti-clockwise direction. So that is a standardization and uniformity. Uniformity across all branches, mathematics, computer science, analytic geometry, standardization and uniformity everywhere that you order the vertices anti-clockwise. So we have a summary, a comparative chart, the convention, older textbooks versus modern style, start position. In older books, top left was a starting position. In modern style, bottom left is a starting position. Vertex ordering, it was clockwise in older times, modern style anti-clockwise. The reason why they did clockwise was visual and diagram ease, and the reason why now they are preferring anti-clockwise is mathematical and computational reasons. You can see the animation the old style and the new style. So why anti-clockwise? The final summary. The prominence of anti-clockwise naming for polygon vertices and recent literature stems from alignment with mathematical orientation, area calculation, and standardized practices and geometry, computer programming, and computation. So we want to standardize them and make a consistent system. So that's why we prefer the anti-clockwise system. So that was a discussion why there has nowadays been a shift start at the bottom left and the naming go anti-clockwise while naming polygons for labeling polygon older textbooks they started the way at the top left and moved a label a quadrilateral so ABCD we are moving towards a ABCDE the way in which we are moving towards a consistency. The preference whether you are doing analytic geometry or trigonometry or computational graphics. If you could see some old spatial database, maybe belonging whatever to your grandfather's time, be consistent. And they prefer consistency across all platforms. Left. That is the reason and why even in primary level school textbooks, they prefer starting at the bottom clockwise and moving anti-clockwise because that would be most the system of the modern higher mathematics books. We shall be coming back from more useful videos, not top more left, informative videos. So, and they move anti-clockwise. Join us anti-clockwise. Subscribe to our channel, share our channel, like, and also comment. How so did you like this video? Has shifted. So we shall come back from top left to bottom left. Have a nice day. Instead of going clockwise, they go anti-clockwise. So this is the difference from the old system to new system, and there is a specific logic behind this change in naming convention, behind the preference for changing the naming convention starting from the bottom left instead of top left, going anti-clockwise instead of clockwise. So the specific reason behind this change in naming convention, this is what we will discuss today.